sensor. It's 2 times faster than Kinect, Microsoft Kinect. Also, we use one Microsoft Kinect as a speech sensor. We use its microphone array for speech recognition. And one of the most innovative things in this robot is using Microsoft speech recognition engine on Rust under Linux. We use 2 laptops. One is Windows-based. Oh, you can see the robot is doing this. One of our laptop is Windows-based for Microsoft speech recognition engine, and the second is Linux-based for Rust. And the 2 laptops communicate to each other with UDP protocol. We also we also publish this stack for Rust, open source. And one of them another innovative thing in our robot is jump bar. Jump bar is designed for wheelchair and for handicapped people. And I think we are the first in the world which operate this totally autonomously. And also we publish the driver open source. And you can see the other things in this. If you have any question after the test, here. Can you make it ask questions now? I'm here. If anyone has a question, I'm here. SRGS, thank you. Thank you very much.
The next team would be Team Dongyang.
Yes. Hi everybody. I am the one of team members of Dongyang team from Thailand. So we have 8 members and 1 professor in our team. So we are study all in mechatronics department. And our robot is named Jarvis, as you see in the figure on the presentation. So the main structure of the robot consists of 3 of components. First is the body, second is base and arm. So we try to build all structure with ourselves. And the robot's size is 40 centimeters wide and 50 centimeters long and 150 height. So our arms have 5 degrees of freedom. And 1 degree of freedom are the vertical level movement. So our robot, the Jarvis, is differently from another robot. I don't know because we use Microsoft Visual C# for programming and use the Microsoft Kinect SDK for image processing or skeleton tracking. And also, as you see in the figure, so number 1 is the first Kinect. The first Kinect used for face recognition and skeleton detection. And number 2 is the second Kinect. This is a Kinect for Windows used to object detection. So number 3 is a laser range finder. Number 4 is a robot arms. And number 5 is a driving wheel base. We use the mechanism wheels. And number 6 is a display. And number 7 is the laptop used for processing. And number 8 is a speaker. So number 9 is a microphone. So we didn't installation here. And number 10 is start button, or you will see on the back of the robot. Number 11 is the emergency stop. It's near the laser range finder. So
this button.
and this is our face recognition and the object detection. We use the image processing by programming in the Microsoft Visual C#. And we use a great app and stacking data for education and localization.
And so I'll allow it now.
And
Next year, the button
now
has to be
we try to our destination.
otherwise.
So any question?
That's not formatting. Can you remove the robots?
Also, there is no cover. Yes. You should kind of make some cover for the roads. Because this is what we did not want to see anymore.
You have 2 more minutes.
Okay. Any question?
Like some cover.
Okay, sorry, we half not enough time. But I will try very
So this is our first time here, or as
Yeah.
the Thailand, the containing robot is about 30 kilos. And we use 4 motor to drive.
You have 1 minute.
Okay, any question?
Lots of teams are now using ROS to operate their robots. Why did you choose to use something else?
So because I think it's very easy.
Competition since 2009, coming also to the competition each year with a new team. So mainly consisting of bachelor and master students at our university. So we have a main emphasis. So the main emphasis of our robot is on acting in real world, easy handling of for native users and robust system behavior, and so that the robot is able to learn, adapt and evolve. So one of the main points with interacting with naive people is that they don't know exactly what the robot might understand, what not. They are frequently unsure about the state of the robot, so you need to think of dialogue strategies where the robot can also take initiative and lead the user through the interaction with the robot. In terms of robustness, so typically you are acting in maps that you have pre-annotated and recorded. So at least for the open challenge parts, we also go to scenarios where you don't know the map before and still try to analyze what you find there. So for example, driving through the apartment and noting where there are planar surfaces, for example, where you can, for example, put objects or where might objects be placed without having a pre-annotated map where these kind of places are is very important. It's also, we have also tried to do a lot of work now to use with the robot arm. So we repositioned it on the robot so that we have a more extreme height from low to up to operate there. We also try to analyze then, see not only where the object there is to grasp, but also which kind of other objects are standing around that might be obstacles for the trajectory of the arm. So we did some kind of forward simulation to find good ways to grasp an object. And it's also that the lower level of sensors, so if the arm really hits something, we also try to catch the exception from the motors in order then to remove the robot arm to a safe position. Because we have always new team members each year, we also look at the kind of software architecture around it. and there we try to build our system based on different levels. So we have some kind of skills of the robot. On top of that, you can define the kind of behavior for the tasks. And we also saw that there are frequently occurring also problems while the robot is operating. For example, losing the person who it wants to follow, or other kind of unforeseen things. So we have also an element to define informed strategies there that deal with these kind of specific situations, or to decouple these kind of exceptional behaviors from the regular task behaviors. And and we have a dialogue manager. That is using these kind of interaction patterns which model reoccurring patterns in a dialogue. So, for example, very simple example is the greeting of the robot when it faces a person. This can be modeled as a pattern, or if the robot is missing some information to ask for that, or has understood the dialogue partner, then you can also define this kind of typical patterns in a dialogue where the robot then is able to deal with these kind of special situations. So are there some questions from your side?
So
the
time is over. Thank you. To 1 minute.
Okay. I think
You can start, but he's not ready.
Nou, wie zijn wij? Nu komt Golem en dan zijn wij. Dus daar die.
Next is Team Golem.
Hello. Before I start, welcome to Mexico. I don't think any of the teams of Mexico have said that, so welcome to Mexico, everybody. We're Team Golem, and this little right now is called Golem as well. The basis of our research is based on a concept called dialogue models, with which we try to describe the task that it's trying to do. So basically, partially you cannot see that very well, but it's basically a very abstract way to say how to carry out a complex task. However, because of that abstraction, there's also another level in which you can present different ways in which you can achieve a basic task. For example, saying hello can be this, or saying hello. But from the dialogue model perspective, it's ported to our service robot situation. In this case, it was just a matter of adding new technologies such as face recognition, arm manipulation, etc. And in that way, because everything over here from the dialogue model point of view is very, very abstract, everything that comes on the bottom side is still something very, very, it can be interchangeable. By that way, the challenge is our orientation by sound, in which a person is interacting with the robot and saying, okay, we're going to be doing this, we're going to be doing that, and somebody else that is outside the visual range from the robot says, hey, put attention over here. The robot will be able to return and say, I'm actually doing something with somebody else, I'll be with you in a minute, come back, finish this task, and because he will remember that somebody else told him something about it, he will turn back and say, oh yeah, I remember you were saying something about something else, what can I do for you? Again, because this is something based on a very abstract model, concretizing it.
Der reflektiert. Genau das Gleiche.